Hi, this is Thomas. Welcome back. Our topic is trigonometric identities. This is example 5. Our requirement reads, solve 3 cosine 2x minus cosine x plus 2 equals 0 for the interval 0 degrees is less than or equal to x is less than or equal to 360 degrees. Moving to our algorithm, step 1, identify scenario. In this case, we're dealing with an equation. Step 2, identify relevant trigonometric identity. We see cosine 2x and cosine x in the same equation, so we're going to use the double angle identity for cosine 2x that will result in some form of cosine x, and that identity is cosine 2x is an identity with 2 times cosine x squared minus 1. Step 3, substitute. So into our original equation, 3 times cosine 2x is going to become 3 times, and replacing cosine 2x, we use 2 cosine x squared minus 1. Continuing with the rest of the equation, minus cosine x plus 2 equals 0. And step 4, simplify to solution or desired expression. Here we're solving for the value x. We might have more than one solution. Let's distribute the 3. 3 times 2 cosine x squared is 6 cosine x squared. Minus 3 times 1 is 3. Minus cosine x plus 2 equals 0. So we see we're going to be working with a quadratic equation. Let's combine the two constant terms. 6 cosine x squared minus cosine x minus 3 plus 2 is minus 1 equals 0. Now we will factor into two linear expressions. With some trial and error, we get to 3 cosine x and 2 cosine x plus 1 and minus 1 equals 0. And our two solutions, cosine x equals negative 1/3, or cosine x equals 1/2. Continuing our algebra, we want to solve for the inverse cosine of negative 1/3, as well as for the inverse cosine of 1/2. Now let's add in a coordinate plane so we can visualize where our solutions lie. Starting with the first equation, inverse cosine negative 1/3 is x. We're looking for an angle with a negative value for cosine, which means the x value is negative. So we are, for our first solution, looking in quadrant 2 and in quadrant 3. We'll have one angle in each of these quadrants with a cosine value of negative 1/3. Our interval is 0 degrees to 360 degrees, so we want to find each of these angles one time. We'll use the calculator for the first equation. Inverse cosine of negative 1/3 gives us a value of 109.5 degrees. That's the value that is in quadrant 2. In order to find the other angle that has the same cosine value, the equation we're going to use is cosine of theta equals cosine of 360 degrees minus theta, which gives us a value of 250.5 degrees, which is our second solution for x. I'll add some notation to the coordinate plane to show that the reason we're looking in quadrant 2 and quadrant 3, because in these quadrants the cosine value or the x value is negative. Now moving on to the second equation, inverse cosine of 1/2 equals x. In this case we're dealing with a positive cosine value, so we'll be looking for the second solutions in quadrant 1 and quadrant 4, where we have positive values for cosine. You might be able to solve in this case without using the calculator. The angle with a cosine value of 1/2 is 30 degrees. And if we apply the same relationship in equation 2 that we applied in equation 1, cosine of theta equals cosine 360 degrees minus theta, then we will end up with our second angle, 360 degrees minus 30 degrees. 330 degrees is a second solution for our second equation. Now we can summarize 4 solutions. X equals 30 degrees, 109.5 degrees, 250.5 degrees, and 330 degrees. Note that these 4 solutions are based on the given interval. If we had an interval from 0 degrees to 180 degrees, then we would have 2 of these 4 solutions. If our interval had been from 0 degrees to 720 degrees, we would have another 4 solutions. So always in solving a trigonometric equation, take into consideration the given interval. We've completed our requirements, and this concludes Trigonometric Identities Example 5.